Hi students, in this video we're going to look at congruence. Alright, so after watching this video you should be able to define congruence and its notation. You should also be able to recall the rules of congruency and how they can be used to prove it. Alright, so students, some things you'll have to recall from previous year's learning in geometry are the geometric property axioms for angles at a point. So things that might include would be things like complementary angles add to 90 degrees, supplementary angles add to 180, angles in a revolution add to 360, and vertically opposite angles are equal. So those are the sort of ideas and axioms that you'll need to recall, along with the ones for your parallel lines. So that alternate angles are equal, co-interior angles add to 180 degrees, and corresponding angles are equal. Right, so some of those things you should be familiar with. And also for triangles, things like all angles in a triangle add to 180. For an isosceles triangle, two angles are the same size. What other ones have we got? Exterior angle of a right angle triangle is the sum of the two opposite interior angles. Those are some of our rules that you'll need to remember throughout this geometry unit. Another good thing to remember is that the sum of the angles of an n-sided shape is equal to 180 times n minus 2 degrees. So for example, a triangle where there are three sides, the sum of angles will be 180 times 3 minus 2, which is 1. So that sum of the angles of a right angle triangle should be 180. For something like a pentagon that has 5 sides, the sum of all the angles should be 180 times 5 minus 2, which is 3, which is 540 degrees. So that rule might be helpful in terms of working out how many degrees you should have in a 5 or 6 sided shape. Alright, so some things about congruence. Firstly, what is congruence? Well, two objects are congruent when they are exactly the same shape and exactly the same size. So same shape, same size, that means that two objects are congruent. Now, what does that actually mean practically? So mathematically speaking, the corresponding angles of our objects, in particular our triangles that we're looking at in geometry, they must be equal size. Now what that means is that if our triangle has angles of equal size, that means our triangles are the same shape. This next step also adds to that congruence. Corresponding or matching sides, that's what corresponding means, must be of equal length. That makes our shape the same size. So corresponding angles makes our two triangles the same shape. Sides being the same length mean that our triangle is the same size, not just the same shape. Now in terms of notation, if the triangles ABC and XYZ are congruent, we write that using this, what we call an equivalence sign. It's an equal sign with an extra line. But we call that equivalent or congruent is the notation for that. Now the key thing to note is that if we've got some triangles, the letters are meant to correspond to each other. So for example, if point A is at the top here, then point X must also be at the top, or with the same angle. In the same way, if B is down here, then Y will be matching it, corresponding, C will be here, and Z will be here. It doesn't necessarily mean they're going to be in exactly the same spot, but the angle at A should be the same angle at X. The line from C to B in our other triangle should be the same as the line from Z to Y. So it could be in a different rotation or different orientation, but that notation stays the same. Now there are 4 conditions that we need to know that satisfy congruence. And it's important to know all of them. We'll be using all of them in our proofs. So the first one we call SSS, just short for side, side, side. So all corresponding sides are equal. So looking at our diagram here, AB has one dash, that is equal to XY. BC has two dashes, that's congruent to YZ. CA has three dashes, that's congruent to ZX. All of those sides are equal lengths. That also means all the angles are equal lengths, all equal size. So those shapes are congruent, they are exactly the same. Our second one is SAS. So two corresponding sides are equal, and the included angle. I will come back to that included angle in a minute. So AB has one dash, so does XY. So they are corresponding. BC is equal to YZ, again, two dashes, so they are equal, and the included angle is the angle in between those two lines. At B and Y, it's in between in both situations, so those two shapes are congruent. Now the angle has to be included, right? It has to be in between the two lines we know. If our angle is over here at A, right, and over here at X, we cannot say it's congruent. There's a reason why the A is in between the two S's, but the angle has to be in between our two sides for congruent. Right? There's no other way. The angle can't be anywhere else. It has to be between our two sides. Okay, next we've got SAA. So two angles in and any corresponding side. So in this case, as if you've got two angles that are the same, any side being the same as well makes it congruent. The reason in this case why it could be any side is because if you know two angles, realistically you know all the angles of a triangle, because you can subtract them both from 180 and you know the angle that's left over. So if you know two angles, you know all of them, or if two angles are the same, they must all be the same. And then if one of the sides, one of the corresponding pairs of sides are equal, then that means we've got congruent shapes too. Lastly, RHS. RHS stands for right angle, hypotenuse, and any other side. So in this case, both our shapes have a right angle at D and U. The hypotenuse is the same length, WV and FE. And then finally, we've got another side that's the same. So here, DE and UV, they're both the same length. So we've got our right angle, we've got our hypotenuse, and we've got our other side. That makes these two triangles congruent as well. Alright students, so after watching this video, you should be able to define congruence and use its notation. You should also be able to recall the rules of congruence. And we're going to use those in some proofs in our next lesson.